TDB has features that let you inspect asynchronous tasks and display task dependencies, and that can be really handy for figuring out why async code hangs or misbehaves. Here's a demo using an example from the TDB Git repository. It creates 6 async tasks which are interdependent in a non-obvious way. There are a couple of things I want to point out in the code. When I call the create task function, I'm using the name keyword argument to assign names to each task, and I'm assigning it the name of the function that is being called. And if you don't do this, Python will assign names for each task with names like task-1, task-2, and that's not helpful at all when you're inspecting the code and looking at task names. By giving it a name, it'll make it much easier to associate what the task is with the function that's being called. The second thing is much less obvious, and we have to run the code to show you what that's all about. I'm going to run TDB on this, and I'm going to hit C to continue, and immediately after that I'm going to hit P to pause the program so I can inspect the tasks. Here we go, C, P, and it failed. TDB wasn't able to get a hook into the event loop to give us an opportunity to inspect the tasks. But it's an easy fix, and let me show you that fix. The second version of this program has an extra function that does nothing but sleep in a loop. And I'm going to create a task for that sleeper function, but I'm not even going to call it. That has the effect of keeping the event loop alive, and TDB will be able to get a hook into the program. Adding this function has no bearing at all on the overall running of the program. So this is a benign thing that you can enter into any problem or any program that you have trouble attaching TDB to. Let's run it. Again, I'm going to hit C and then P to pause the program immediately afterwards. This time the pause was successful. I can go up to the top and go to the async tasks and see the count of active tasks. In fact, if nothing else, just this count of tasks can sometimes be a real indication about what's going on. If this number is crazy high, you're spawning tasks maybe in an out of control manner. In any case, here's my task list, and I still do have a task-1 that Python named, and that's actually in the main program when it does the gather. All the others are functions that I created. If I hit the letter G, I'll see a task graph, and these are all the interdependencies between the tasks. And this can really be helpful when you're trying to figure out why one thing doesn't fire. It may be waiting on something else. Now, technically, this should be a directed acyclic, a DAG, a directed acyclic graph, but I don't know of a way to plot that DAG relationship inside of textual. If I hit G again, the task graph will go away. I can scroll in here to see what line of code the individual tasks were running at. And if I hit escape, I'll get out of this. That's a brief overview of the task graphing relationship or task graphing capability inside of TDB. Take a look at some of the other videos to see how to inspect multiprocessing processes.